Hello again. Today we're talking about Swift basic operators. So let's get started. In Swift, we have an assignment operator. Let's see what that looks like. So here we'll have a variable. Let's create a variable called A. A has a value of 34. Let's print A. Currently A is 34. If we run our playgrounds, we should see output of 34. We do see output of 34. Great. Next, we could reassign. So now I'm going to reassign A 10. This is called reassigning. Right? So reassigning using the assignment operator. And the assignment operator is one equal sign, not two equal signs, which we'll get into later. So assignment is one equal sign. What it does, it from A being 34, now it basically updates its value to now be 10. So if we were to print A, like we saw, A before was 34, now A is 10. We could use some string interpolation to make this read easier. So before or A began as just string interpolation again for review. So A began as A, and here we could say now A's value is A. So we get a better print in our console. So now we'll see A began as 34, now A's value is 10. Again, this is the assignment operator. Basically, it updates a given variable. Only works on variables, not constants, as we saw in the earlier video. So a constant, for review, a constant cannot change. So if I made a let, a constant, I'll get a compiler error here saying cannot assign a value to a constant, right? So this only works on variables, assignment, like reassigning values. Great. Let's keep going. Next, we have arithmetic operators. Back in math class, we always use addition, subtraction, multiplication, and division. As we'll see later, now we have a next operator, which is the remainder operator. So let's see what addition looks like. As expected, I should be able to add numbers. So here I'll say addition. I'll add, say, 56 plus 4. I'll print addition and run my playgrounds. And addition is 60. So this is 60. Next, we'll take a look at subtraction. I'll say subtraction equal to, let's say, 65 minus 5. And let's print. Let's get in the habit of using string interpolation. That way our console log makes more sense when we read it. So subtraction value is subtraction. And here we're using string interpolation. We have our string and we interpolate it. We use a placeholder syntax here, which is called string interpolation. Again, this is review. So string interpolation. Basically, at runtime, it uses the actual variable subtraction here, and it prints it out. So if we run our playgrounds, subtraction value is 60. 65, take away 5 is 60. Next, let's go to multiplication. So multiplication, we'll say 10 times 10, and print result of multiplication is multiplication, like that. Run our playgrounds, result of multiplication is 100, right? 10 tenths is 100. Going on to division. Division of two numbers here, we'll say 20 divided by 5. And here we will get our answer, and we'll say print result of division is division. Like that. We'll run it, and we'll get 4. So let's actually flip this a little bit. So division here happens to be, if we option click on it, it's an integer. Okay, if we say 2.8 divided by, let's just keep it at that for now. And if I option click on it, it's a double. What happens here, from our earlier video when we introduced Swift, we said the compiler will now infer what type division is. So the compiler has inferred using type inference that division is a double, that the division variable is a double. Great, right? How does it do that? Because 2.8 is not an int. 2.8 is a double. So therefore, division is a double. So now let's go ahead and run our code again. And now we have result of division is 4.16, which is a floating point number. It's a double data type. Great. Let's go on to the remainder operator. It's so the percentage, this character here, the percent character, is actually called the remainder operator or the modulo operator. What it does, it gives you back the remainder of an operation. Let's see what that looks like. So here we'll say var remainder. I'll say 9 mod. So mod is the percent sign 4. So basically it does a division and it returns you the remainder. Okay. So here, if we print remainder is string interpolated, remainder, run it, remainder is 1, right? So what is this? I have 9, I try to divide it by 4, it goes into a 2, there's a remainder 1, so it returns us the remainder 1. So this is what we have here. Remainder is 1. Great. Let's keep going. We have the unary minus and the plus operator. Let's see what it looks like. So here I will say positive number, and I'll say positive number is 10, and I will print it. Print, use interpolation, say positive number is, let's actually, we could actually do an operation here. So in the string interpolating code, in the syntax here, in that parens here, you could actually do an operation. For example, I could say 6 plus 10 and run that, and I do get 16, right? So the same way I could take a variable, in our case, our positive number, right? It's a positive number, and I will add it. Let's just add it to itself and run it again. And here I get 20, right? Because positive 10 plus positive 10 is 20. Great. Let us see a negative number. Negative number equal to minus 10 again. And here we'll say print result of negative number plus positive number is, and we'll say take the positive number plus the negative number. So basically what we have here is positive 10 minus 10. This is what we have. And we run it. And here we'll get result of negative number plus positive number is 0. Because if you remember back in math class, if you have a positive and a negative, it becomes negative. So that happens to be 10 minus 10, which is 0. Okay? So this is the unary minus, which is this. And we have the unary plus. Unary means 1. Unary plus, which is this here. Okay? Moving on to compound assignment operators. What does that all mean? Well, if we want to have a number, let's say compound number equal to, let's call it 20, right? And we want to say compound number, we want to assign compound number a value. So basically we want to say compound number plus 1, for example. So our result should be 21 here. Let's go ahead and print compound number is compound number. Compound number is 21, right? As we said earlier. What does that do? It takes, first of all, let's talk about how the compiler works as far as like operations go. So it first does the operation on the right side of the equal sign, not the left. It first does the operation on the right side, takes the result, puts the result to the left operand, right? Again, right side happens first, so compound is 20 plus 1, takes the result of 21, puts it into the compound number variable. Okay, so that's how it works. So we could shorten that up by using the compound assignment here. So plus equal or minus equal, instead of doing this operation we have on 46, we could make it shorter by saying plus equal 1, just like that, right? Currently, our compound number is 21. So if we say 21 plus 1, we should be getting 22. So let me just copy line 47 and run compound number again. And here we get 22, right? Using the compound assignment operator, right? It works the same way as in minus equal. So if here we say instead of plus equal, we say minus equal, currently our value here is 21. So if we minus 1, we should get 20 here. Let's go ahead and run. And indeed, we get 20. Again, we had 21. We used the compound assignment, right? And it removed 1 from our current value. And now we have 20, okay? This is also called decrementing as we go further into the course. So what we did on line 49 is decrement. Decrement is basically remove a value, or remove, not a value rather, but remove a number. In that case, we removed or subtract 1 in that case. So think about it as the same as saying subtract. Right? So here we decrement by 1, we subtract 1. So here I could say decrement by 1, subtract 1. On the earlier version where we did plus equal, which I removed currently, but we have decrement and we have increment. So increment looks like this. If I say compound number plus equal let's just say 100. This is saying increase by 100. Okay, so plus equal is increment, minus equal is decrement, to subtract. Increment is to add. Great. Moving on to comparison operators. Here we'll create some values. Let's say var x equal to 5, var y equal to 10, and let's do some comparisons. So here we'll say print x is equal to x, right? So this here should be true. Next, we'll say print x, or rather y, is greater than x, meaning is 10 greater than 5? Here, we should get true. So basically, the comparison operators, they compare two values, right? Is x equal to x? Yes, it is. Is y greater than x? Yes, it is, because y is 10, x is 5. We also have other operators here. We could say less than, so is y less than x? Well, this is false because y is 10. 10 is not less than 5. Keep going. Let's go to greater than or equal to. So we'll say, is x greater than or equal to x, right? Is 5 greater than or equal to, or equal to? It's also equal to, so this is going to be true. And lastly, we'll put one more, not equal. We'll say x is not equal to y, which is true, like that. Let's go ahead and run. And here we have true, true, false, true, true, as we predicted, as not predicted, but as we calculated, because this is what we had. Okay, great. Let's keep going. Next, we have the ternary operator. This is interesting here. So as I said earlier, we'll be looking at control flow later in the program. But for now, if we were to have a value, let's say var result of ternary operation, we'll put in 100 here. Or rather, let's just put in, no, this is fine, 100. So here we'll use the if else statement. So we'll say if result of ternary operator is greater than 80, print, we'll just say number is greater than 80. That. And we'll say else, print number is less than 80. We'll go ahead and run our code. And we'll see number is greater than 80 because currently the number is 100. And again, we'll look at if else statements further. But here we're saying if this is true, go ahead and print number is greater. Else, if it's false, else if false, go ahead and print number is less than 80. Okay. We could also do let message equal to result of operation is greater than 80. Go ahead and just put in this first message here. Or go ahead and do this message here, right? And print message. In that case, this is fine. This is good. Let's actually change our result message here by using the assignment operator that we saw earlier. So here I'll do 75. So we just changed what the value of result of ternary operator is. And let's run the code. Okay, so the first one, it's 100. So it prints out number is greater than 80. We changed what result of ternary operator is on line 79. It's 75. So now using the ternary operator, ternary is 3. It takes in 3 statements. The first statement here has to evaluate to true or false, right? It has to be a Boolean calculation, true or false. The second, if it's true, the question mark here, if it's true, this statement will get executed, or basically this statement will get assigned to message. Else is the colon, else this statement here, number is less than 80, will get assigned to message. And we simply just print out the message on 83. So the difference between the ternary operator and the if-else statement is we have 4 lines of code here. And with the ternary operator, we have 1 line of code, right? So there's use cases as we see further along in Swift and iOS development. There's use cases for the ternary operator where it's better, faster to use the ternary operator. And there's cases where it's easier to read using the if-else statement, okay? So this is the ternary operator. Again, we have 3 statements. The question mark is if it evaluates to true, and we have the colon if it evaluates to false, right? So first, the compiler checks this condition. If it's true, it executes this line of code, and it's done. If it's false, if this condition is false, it go ahead and it executes this line of code. Okay, great. Let's keep going. Let's talk about nil coalescing. We did see that earlier. So here, again, I'll use a similar example we had earlier. Here we have a number. I'll say input number from user. We took a string from the user. We told them to enter some number from 0 to 9. They entered 56. Okay. When I say 0 to 9, you could use 0 to 9. So they entered 56, which is valid. And we went on to say, OK, now we have the input from the user. Let's go ahead and convert that for us to use. So we said converted number. And now we will use the int initializer. The int initializer here, we'll talk more about initializers. We'll use the int initializer to take an input number like this. And now, as we spoke about yesterday, this is going to create what's known as an optional. Here, I'll have an optional int. This is not an int anymore. It's an optional int. Optional int. Okay. I want to go ahead and use that converted number. We agreed with our application that if the number is invalid, we'll use a 0. So this is where nil coalescing comes in. If the user entered an invalid number, we'll use 0 as the default. So for now, we'll say print user entered some number. And here we'll actually create a variable. We'll call it, actually, it could just be a constant. We're not going to change it again. This could also be a constant. And this could also be a constant. So here we'll say valid number. And valid number, we'll use nil coalescing for that valid number. So we'll say converted number, which is an optional. This is an optional, as we spoke about yesterday. And we'll say converted number. If it's not valid, go ahead and use 0. So 2 question marks is the nil coalescing operator. If converted number is not valid, go ahead and use 0. So here we'll use valid number, and we'll go ahead and run. And here we have user entered 56 because this is a valid number. But what if the user entered 56 like this? We told them to add digits, but they decided to add 56. And we run our code. We converted the number, it's an invalid number. We went ahead and we used our 0 as a default number. User entered 0, and then we could go ahead and figure out, is 0 valid, or maybe we want to have a different number to indicate invalid numbers. So that's what we could do here with the nil coalescence operator. We give it a default number when we unwrap that value. Great. Let's talk about close range. So here we have close range. What is close range? Well, we'll talk about loops as well. But for now, if I want to go ahead and print some values, I could use the for loop. Say print some values from 0 to 10, for example. Here I'll say print values from some index in. We'll come back to loops from 0. 3 dots indicates a close range. So basically, I want to include everything from 0 to 10. So this is a close range, 3 dots. And I want to go ahead and print. I want to go ahead and print some index or some number. Let's just change this to number. Number and number, like that. And now I'm going to go ahead and run it. And it prints 0, including 10. This is close range. Include everything from the beginning number, the lower range, to the upper range or upper bounds. Let's take a look at what half open range is. So we'll use our same for loop. Again, we'll talk about loops later. We'll say for number in 0. This time, we do not want to include 10. If you don't want to include 10, we'll use what's known as a half open range with the less than sign here. And we'll say print number. And now if I run it, I'll have 0 to 9, not including 10. Let's take a look at one-sided range. Here, we'll actually create an array. We'll talk about arrays as well. An array basically is a collection. Here we'll have a collection of numbers. So we have a collection of numbers. Think about it as a bucket. You have a bucket of numbers, 1 to 7, and we want to see what one-sided range looks like. We'll just print array. If I print my whole array here, let's just see what that looks like. I'll have all my numbers. So I'll have all my numbers from 1 to 7, as we had before. But if I want to print a selected amount of numbers in some range, I could say array, go ahead and print, for example, from the beginning of my array to the way you count arrays. Again, we'll come to arrays more later. So the way you count arrays is from 0. Normally we count from 1 as humans, but computers, we count from 0. So 0, 1, 2, 3, 4, 5, 6. So here we have 6 indices. Again, we'll come to this later. But basically, if I want to print from index, for example, 0 to 2, I'll do 3 ellipses, and I'll do 2. 2 indicates the index. So go ahead and print index from 0, 1, 2, including 2. So we should have 1 to 3 printed. If we go ahead and run that, we have 1, 2, 3 printed, right? So this prints 1, 2, 3. Great. On the other side of the spectrum, if we want to go ahead and say array, I want to print from some index, let's say 3 or 4, all the way to the end of my array. So if we count from 0, 1, 2, 3, 4, it will print from 5 to the end of the array. Let's go ahead and run it. So here we have 5, 6, 7. 5, 6, 7, right? It started from index 4 all the way to the end of the array. The end of the array is when you get to 7. Great. Let's keep going. Lastly, we have logical operators. So basically, I could have a logical operator like this. I could say if 5, let's do an operation. If 5 is greater than 7, this evaluates to true. So 5 is, no, sorry. If 5 is less than 7, which evaluates to true. And let's have a next operation here. If 4 is greater than 2, which also evaluates to true, go ahead and print true statement. All right, else statement is false. Okay, so what happens here? Let's go through this code. So in my parents here, I have 5 is less than 7. That's true. Let's just keep track of this. True. And let's evaluate this operation. Is 4 greater than 2? Yes, it is. So that's also true. So the way this works, true and true evaluates to true. So this entire operation evaluates to true. And as we said earlier with our if statements, if the condition is true, it will go ahead and print line 115. So here we have true statement printed, right? Let's go ahead and copy that block of code and try this again with our OR. So OR is double pipe, right? So here we have, let's change our operations around. So this one will stay true, and this one will keep this, we'll make this one false. So here, if we go again, 5 is less than 7, which is true, or 4 is less than 2, which is false, right? So true or false evaluates to true. Let's run this. True statement. On the other hand, let's copy this, same block of code. On the other hand, if we were to say and here, change this to and. So true and false evaluates to false. Let's run the code. And here we have statement is false, right? So true and true is true. True or false is true. True and false is false, okay? And lastly, let's take a look at the not operator. So this is the not operator. And let's see what that looks like. So let's create a variable. Let's call it is Friday. And let's say true. And say if is Friday, print TGIF. Let's run our code. And it's Friday. This is true. Our if statement evaluates to true. So we go ahead and print TGIF. Else, let's print a next statement here and say just another day, like that, and run the code again. Nothing has changed, right? It's still TGIF because our statement is still true. This statement is still true. With the not operator, we could reverse or basically toggle, right, or swap, right? So the not operator, if I have not true becomes false, right? Again, here I have the not operator. I basically reverse what true is. I say true is no longer true, it's false. Same way if I say not false indicates true, okay? So this is basically what's known as you toggle or you swap. You toggle or you swap the value or the Boolean value. The Boolean, let's just say Boolean value. Okay. So here it's still true. If we want to go ahead and swap it, make it false, because this is true, we just put in a not operator, the exclamation mark. And if we run it again, this time around we'll see just another day, which is this statement. Because now this is false. And again, it only evaluates to our print statement here if this is true, but now this statement is false. So we go to just another day. Again, thank you for watching. See you next time.